All right, so before we start, we just need to do one thing. Mary, could you please stand up for a sec? So 3, 2, 1. Happy birthday! All right. So go ahead. Hello everyone. I'm Khalid, game director on Team Flaming Toast. We're a team from all over the world. We're 55 people. We joined forces to make an awesome game. We're here to present what you once knew as Tree of Life, but what is now called as Bloom. Yeah. So, Bloom is a 2.5D adventure platformer for PlayStation Vita. You're in control of this tiny character called Sprout. See how cute he is? His name is Sprout. His name is Bloom, man. All right. Can I continue? So, Bloom is a 2.5D adventure platformer for PlayStation Vita. You're in control of Sprout, and Sprout has control over all the powers of nature. He can grow spikes out of the ground. He can even control wind. And what he needs to do is use these powers to defeat these evil robots that gain control over our planet. Eventually, he needs to give Mother Nature its power back. Obviously, all games start off with design, and to tell you more about that, I'll introduce our lead designer, Cliff.
Hi everybody. As Khaled said, every game requires a base of design. We started out trying to pick out a theme. So we picked out nature versus machines as a base, and we worked to build a mechanic in order to have the player remember this theme throughout the entire game. We came up with the mechanic of growth to be able to have the environment affected by grass and other visible plant life to be able to remind the player, and we used concentric design to build off of this one mechanic to be able to design a huge feature list to be able to pass off to our engineers. And here's our lead engineer, Peter, to discuss how we handle our features.
Thank you, Cliff. So once we had our goals established for fall semester, we identified our primary engineering challenges. We knew we wanted 4-player co-op multiplayer. We wanted a robust AI system that could support modular enemies. We wanted a procedural grass system that interacted with the player and the environment. And we wanted to build to PlayStation Vita. So to do this, we used something called feature pod system. Feature pods originally were intended to be integrated teams of designers, artists, engineers, and musicians. They would be working together to complete one feature. The idea is that the feature pod is not complete until the feature is complete. That means code complete, design complete, everything. We didn't quite get there. What ended up happening was our engineering team outpaced everybody else, and so we ended up with something more of like an engineering feature pod. So as you can see here, we have one pod lead. They work with 2 to 5 other engineers to work on their feature over the course of 1 week. The main goal of a pod lead is to sort of organize a team, design the system, and come up with a great plan to implement everything. So how do we organize such a large team? Our producer, Jordan, will tell you more about it.
Yep. So as we said, our team is 55 people deep. So to organize it, we use a production software called Handsoft, which allows our leads to assign tasks as well as manage overall development milestones. For example, if we assign the task walk, it would show up in that person's to-do list as not done. As soon as they start the task, they'll mark it as in progress and comment what progress they've done thus far and any problems they've been having. And finally, when they complete it, they mark it as complete, which automatically notifies myself and the other leads of their progress so we can gauge how the entire team is doing. Handsoft was first incredibly successful for the engineering team, and soon we brought it to design, audio, and art. Bryce, our art director, will tell you a little bit more about this organization.
Hey guys, so if you were to ask anybody on our team what the main problem has been, it's been art. We simply haven't had it, and for the first 7 weeks, engineers have had to use grayboxing, build their own models and their own animations with no temp art to be put in place. And if you want to know why, pretty much long story short, we had 2 previous art directors who just didn't really work out, and we were starting from scratch 3 weeks into the semester. Not only that, but we had a first-time, totally inexperienced art director, me, so this could have gone really badly. Needless to say, we knew what our priorities were, which was to create an art pipeline that was efficient, organized, and would help us catch up. I could tell you some of the details of that, but really, we've learned that it all boils down to one thing, which is communication. Since our entire art team is working remotely, having regular open communication has been critical. Things as simple as answering emails concisely, clearly, and immediately have been the secret to our success for getting back on track. One thing to note as you're looking at this concept art is that we still set the bar very high for ourselves. Colette has been insistent that this needs to be a blockbuster caliber game, and it's also art-driven. I mean, it's a platformer, but we learn the story through all of the art that we encounter. And so in order to reach those goals, we've grown from 7 artists when I first started at week 3 to over 30 artists who are all international. And as you saw from those flags, we have people from Puerto Rico to Belgium to London to Brazil. So definitely communication has been extremely difficult, and I would not be able to coordinate it all on my own without the help of our new art producer, Adam Smith.
Hey, so my name is Adam, and I'm a new art producer. So as he said, I'm actually another point of communication with the art team. I was originally brought onto this as an engineer. So being a point of communication for the artist, I'm also a point of communication for the engineering team and the design team. I make sure that the assets that the art team delivers will actually work well in the game, make sure that the engineers and designers know how to use it also. I'm also making sure that all the art assets get imported into Unity correctly so that everything will work smoothly with our pipeline. And now we'll talk about a little bit design with Pete and Cliff.
Thanks, Adam.
Cliff and Cliff.
All right. So once our design process begins with what we like to call whiteboarding, and this is pretty much an exact simulation of what we have going on, as probably the other lab groups have seen. We get our designers together, draw on whiteboards, and make sure that we iteratively design specific levels that we'd want to have in the game, and refine concepts to where once we're set on a specific level or detail, we pass it off to Graybox. We pass it off to Graybox for us to be able to handle usability testing.
So after whiteboarding, we do something called grayboxing, which is basically using color-coded Unity primitives to build our entire level. The level should be mechanically complete. We pass it on to our awesome usability team, and they test it out every 2 weeks, and basically we iterate according to what they say. We got stuck with this graybox level for a long, long time. But then thankfully, Bryce came along and, well, this happened. I didn't expect we were gonna show that.
All right, a special shout out to our composer, Max Lowe, for the music you're listening to. And what you're looking at is our first level. And, sorry, this mic. And so this first level, what's interesting about it is it was actually created in the last 2 days by myself, Richard Turner, I'm sorry, Peter Turner, Richard Cho, I get them mixed up. Yeah, so yeah, just the last 2 days, which is a great testament to how organized and efficient we have become. This is the execution on the Wind Waker-inspired toon-shaded aesthetic. We're going for simple shapes with charming lines and a muted color palette. And since none of the art team is here, they're all remote, but they're going to be able to watch this later, I'd like to have you all help me in giving them a special round of applause for doing such great work.
Okay, so this is our first level, it's the junk level. This basically tells the story of how junk gets broken down, melted down into later levels where it gets melted down to lava and it's eventually used to create the robots that you see in the rest of the game. The main design behind this was to teach platforming, like simple platform mechanics of running, jumping around, wall jumping, that sort of stuff. This leads into the next level, which is a lava level, which the player's going to get to start battling against the robots, and also learn how and to use the unique and incredible nature abilities, and also get to play around with it, experiment with it. And to talk about that is Peter Nehar.
All right, thank you. So the first feature that we implemented was our dynamic grass system. As you can see here, as a player moves through the world, grass grows everywhere they go. And grass is fundamental to Bloom because players' abilities cannot be used anywhere where there is not grass. So the first ability that we implemented is the spike. So spike is a multi-purpose tool that the player can use not only to kill enemies, but also as a platform to reach areas they otherwise couldn't. And to talk about the next ability is Nihar. He's been our pod lead on the ability system.
Yeah, thanks. So as Pete said, you need grass for all the abilities, but sometimes you just don't have grass. And like here, there's a huge platform on the other side. How would you get there? Just create a pollen bomb, yes, and smash it against the wall. Boom, there's grass. Now you can use a spike and traverse the wall. Yeah, good job.
The next ability we implemented is our wind system. So wind interacts with the grass, so as you blow it over an area, you can see the grass actually moving with it. But not only is it a visually impactful tool, it's also useful. So the player can use wind to move obstacles out of their way as they move through the game.
Okay, you saw spike. That was awesome. You saw pollen bomb, even more awesome. But could it get better? Yes, it does, because we've got a combo system where players can assist each other, combine their gestures, and create these super awesome combos like the Splinter Spike Bomb. Yep, which will smash these. Oh, they're gone. Yeah, go nature. Woo.
To talk about some more engineering challenges, we have Frank, our lead AI engineer, and Chris, our lead networking engineer.
Alright, so what you're seeing now is called Horde Mode. Horde Mode is a game type that is completely separate from our main story mode. While playing Horde Mode, you and up to 3 other players must grow flowers to protect a tree from endless waves of enemies. So Horde Mode is really good because it highlights all of the abilities we have in the game, and it also shows off the networking capabilities that we have.
So at the start of fall semester, one of the key features we wanted to implement for Bloom was 4-player network cooperative play. And so we started by implementing our own network management system on top of the already built-in Unity networking features. From this, we built a flexible system to access this networking infrastructure that was independent on whatever platform we were deploying to. From there, we added dead reckoning and state synchronization to our game objects through the use of remote procedural calls. This allowed us to synchronize movement, animations, and all kinds of game states across the network for each client.
Alright, so at the end of our second level, our player will encounter our first boss. This half crane, half spider robot protects the exit to our junkyard. So one of the biggest challenges we had when we started working on the crane boss was that we didn't have a model. So that meant that in addition to implementing the AI for the boss, we also had to make a model in Unity. And as you can see, you shouldn't really let engineers do that. Some things to note about our crane boss. The arm is fully opposable, and all of the rotations that the arm makes are done while we're in the game. Additionally, the crane boss has over 10 states that it transitions between, and all of those conditions for transition are fully tweakable by our designers. Alright. So now you've seen, all of the great progress we've made on our game. Jordan's going to talk us through our plans for the future.
So as I hope you've guys seen, from design to audio to art to engineering, progress has been great. This is a target that our art director did 6 weeks ago, and this is an in-game screenshot that we have right now. So yeah, everything's been going great, but as some of our team members have mentioned, we have made some mistakes along the way. We are trying to learn from them, and we will improve. And as a result, we have a new production pipeline, which starts officially tomorrow. This new production pipeline is a 3-week process, which has 4 separate reviews between our design team and our engineering pods to discuss implementation, 2 separate code reviews between our lead engineer and our engineering pods, and additionally, our art director, Bryce, is notified a full week in advance of the assets he will need to assign the following week. we hope to use this entirely new production pipeline to go smoothly all the way to fall demo day, where we plan to have 2 full levels, a completed boss fight, and a completed horde mode. And not only that, but we mean the game to be a very cinematic experience. So as a result, just for you guys tonight, we have a very special sneak peek of our intro cinematic created by Andrew Sakata and his animation team.
So, you've seen what we've done, you've seen our progress so far, you've learned of our new pipeline, and hopefully you're starting to imagine what we can do. We're not here just to make a good game. We're here to excel on every single discipline, be it design, engineering, production, art, and sound. We're here to make a coherent package that is like no other. This was the amazing Team Flaming Toast, and that was Bloom. Thank you.
Questions for Team Bloom? Flaming Toast? Making
Yep.
What made you decide to do the presentation in Engine?
Because